Welcome to a builder's video from the Ultralight Airplane Workshop. What I would like to do in this video is show you how to go from an airfoil file, a .dat file, like in the Selig format, to a template that you've printed out in order to, for example, make a template for cutting out foam ribs, or perhaps making a form to bend aluminum over, or maybe make a jig to make a wooden wing rib, something like that. Now, what prompted this video was a message from one of the supporters on Discord asking about how to do basically this exact same thing. Now, I've done portions of this process in different videos kind of spread out, but I've never really done an end-to-end video on how to do it. Now, since I'm still working on some of my rib design stuff, some tearing apart and ripping apart and bending, doing some testing on that, I thought this would be a good video to put out that I think many people would find interesting and useful. So let's get to it. I think doing an overview here at this point would probably be a good thing to do. There are a number of steps, and if you're in the process of doing this sometime in the future and you can't remember maybe what the next step to do is, up here at the front of this video, you can go to it, take a look, kind of refresh your memory, and you don't actually have to maybe watch the whole video. So let's go over it real quickly. So we need to obtain the coordinates for our airfoil. Now, there's a nice website out there that has a whole bunch of airfoil coordinates. So we'll go to that and we'll grab a Clark Y. Now we're going to get that in the Selig.dat file format. We're going to import that .dat file into a free program called XFLR5. Now, generally these airfoil files don't have very many points to them, and you really want lots of points in order to make the airfoil look smooth. So we're generally going to add points using the XFLR5. Now, once you've got that airfoil the way you want it, you're going to export out the .dat file again and probably save it to a different file name. And then what I will do, and you could use a different program, I'm going to import it into FreeCAD. And FreeCAD makes it pretty easy to do that. In some cases, you don't want the outside dimensions of that airfoil. You're going to want something inboard, inside, just a little bit. For example, you want to maybe subtract out the thickness of the wing skin and thickness of a flange of your aluminum ribs when you want to form an aluminum rib. So we'll go over that. Once you've got that, you want to put it into a technical drawing. Now, in this case, it's a FreeCAD technical drawing. And once you get that, you're going to print it out. Now, frequently, printers don't scale to exactly 100%. A lot of printers will actually make things a little bit smaller. So frequently, we're actually going to have to scale that just a little bit. And I'll show you how to add a scale to a technical drawing, how to measure it, and then we'll go back and reprint out our drawing at the correct scale. Now, here we go. So as I mentioned, there's a website you can go to that has a pretty significantly sized catalog of airfoils. And that is Airfoil Tools at airfoiltools.com. So let's go there. So here's what the main window looks like. Now, like I said, I want to get a Clark Y airfoil. So I'm going to come down here to the C's. And then down at the bottom, there's a Clark Y. Now, on the next page over, there's another one, which is smoothed. That's this Clark Y SM. I don't want to use that just because I want to show you something about how to correct airfoils that have maybe slight issues with them. So let's get this Clark Y airfoil. So we can go to airfoil details to see what it looks like. So you can see up here what it looks like. It looks about right. So let's go ahead and get the .dat file. And so we'll come over here. You can see the Selig format .dat file. Click on that. Now, that won't download file. It'll actually make this page here that shows you all the text for it. So let me quickly talk about the format of this file so you'll be able to recognize it. There's going to be a line at the top. That's the description. This one says Clark Y airfoil. And then there's going to be two columns of numbers. And the columns are separated by white space, basically spaces. Now, the first column is X. The second column is Y. So, for example, this first row is a point back at the trailing edge because the trailing edge is always 1.0. The leading edge is 0.0. So it starts out at the trailing edge, and then as you go down in the file, you'll see these X numbers getting smaller. So we're going toward the leading edge of the airfoil. But you'll also notice these Y numbers are increasing and they're positive. They're above 0. So we're going over the top of the airfoil as we move forward. So let's scroll down here a little bit farther to the leading edge. So here's the leading edge, 0, 0. Now, once you go past the leading edge, you'll notice that these X numbers start increasing again. So now we're moving aft again, away from the leading edge toward the trailing edge. But you notice the Y numbers are negative. That means we're below the chord of the airfoil. And so we're doing the bottom edge of the airfoil. And when we get to the bottom, you'll see we're back at 1.0 again. So now we're back at the trailing edge. Now this isn't exactly 0 here, and that's because we have a blunt trailing edge on this airfoil, and we'll look at that a little bit better here in a moment. So what I'm going to do is hit Control A to select all these numbers. I'm going to select Control C to copy them. Now I'm going to bring up a text editor. This is an empty text editor. I'm going to do Control V to copy my numbers in here. So now they're all in here. So now I'm going to hit save, and I'm going to save this. I'm going to put it at the top of my documents just to make it a little bit easier. And we're going to call this Clark Y raw. .dat. Don't forget to call it .dat. And then I'm going to hit save. All right, I now have that in a file. Now here I have XFLR5. Now this version is 6.57. There's a newer one. As I record this, there's a 6.58. Well, we want to get our airfoil imported here into XFLR5. So let's go underneath Module. We will go to Direct Airfoil Design. Now you can see there's a spline airfoil, but we don't want that. We want our airfoil. So let's do Open. I put that into Documents right there. So we'll open that. So there's our Clark Y airfoil. Let's see, I want to show you a couple of things. For example, let's go to the trailing edge. We'll zoom in quite a bit here on the trailing edge. So you can see this has an open trailing edge instead of coming to a point. And that's why when we're looking at the coordinates in our .dat file, at 1.0 we had a negative on the bottom side and a positive on the top side. That's just because we don't come down to a point at 0, 0. And then let's look at the tip. Now as we zoom in here on the tip, you can see that there's various line segments here. So it's a little bit rough up here at the nose. And in fact, at the tip at 0, 0, it's very rough. You can see that this line here goes at a pretty sharp angle, and this line here goes at a pretty sharp angle. Whereas all these others aren't as sharp. Well, you're going to see that causes a little bit of a problem here in a moment. Let me zoom back out just a little. So let's look at how many points we have in this airfoil. We have 121 points. That's actually not too bad. I prefer to have more just because I like to have things be smoother when I'm in CAD programs working with the airfoil shape. So I'm going to crank this up. Let's go up to 200 points. That's probably fairly good. So I'm going to right click. I'm going to select. Oh, you can't really see it, unfortunately. I'm going to select Refine Globally. You can just barely not see it there, unfortunately. There we go. Refine Globally. Now there's 121 points. I'm going to put in 200 here. Now before I do it, you can see here where it's actually showing where your points are. So you can see they refined the points a little bit more up here toward the nose. You can see quite a bit of spacing between points here, and then it started getting a little closer, but there's an issue. I think there's a couple of points missing. I think there should be one more here. And I think there should be one or possibly two more in here. And I'll show you why. So let's go ahead and say OK. And then you should have noticed that it popped up a whole lot of more points now. And you can see we got a bunch of points that are closer together up here now. So I'm going to overwrite my old points. I'm going to say yes. Now let's zoom in here on the nose. All right, so the leading edge was here at 0.0, and we still go through 0.0, but you can see this, we actually have a leading edge farther out in front here. There's actually some negative X numbers right in here. That's not actually harmful, so I think a couple of extra points in here would have solved it and there wouldn't have been an issue. But I still think this is pretty fine. We're going to go ahead and proceed with our process. Oh, before we do that, I should mention something. I've noticed that some airfoils in the database aren't quite set up what I would call accurately. The leading edge is not always at 0.0, and the trailing edge is not always close to a Y of 0. There's sometimes the airfoil is rotated just a little bit. So you can actually do something about that here in XFLR5. I'm going to right click again. You'll see there's this thing called, well, you can't see it very well, normalize the foil and derotate the foil. And there's other things you can do. For example, this is actually be a good one. This airfoil, if I remember right, was 12% thick. Well, if you're doing an ultralight, 12% thick probably isn't enough. You probably want at least 15% thick. So I'm going to hit Scale, Camber, and Thickness. And I'm going to come up here under Thickness. And I'm going to say, okay, there you can see it's 11.7%. I don't want that. I want 15%. So let's go ahead and say OK. Now you can see where the new one's going to be. Now if you don't like it, you can hit cancel. But I do like it, so I'm going to say overwrite. So now we've changed the thickness of our airfoils. Now I don't want to change the camber. The camber would actually significantly change the characteristics of the foil. So we're going to leave camber alone. The thickness, at least small changes, won't significantly change the aerodynamics of the airfoil, except what thickness normally does. For example, increasing thickness generally let you go to a slightly higher angle of attack before stall, but of course it increases drag. Okay, let's say I'm happy with this airfoil. Let's go ahead and save it out. So I right click again on my airfoil down here, and I come up to export. So I'm going to export it to the same directory, except this time since I'm going to use this Clark Y, but instead of raw, I'm going to say 200. And I'm going to put 15 since it's 15% thick. Now we are done with the XFLR5. Let me say a couple things about XFLR5. It's a free program. I'll put a link down in the description where you can get it. But XFLR5 does a whole lot more. You can actually do analysis on an entire airplane. Not just airfoils. You can actually make wings, fuselages, vertical tails, horizontal tails, put it all together and do some analysis on it. Mostly I just use it for airfoil analysis, because you can actually do two-dimensional airfoil analysis. But I typically use OpenVSP for my airplane analysis. Well, now I've got FreeCAD. Now this is a free CAD design program. Now if you've already got your own CAD design program, there's probably ways of doing what you want to do with yours. I've been using FreeCAD mostly. I'm certainly not an expert in it. There's probably better ways to do what I'm going to show you to do, but at least what I'm going to show you works. So I'm going to come up here underneath File. I'm going to select Open. I'm going to select my file type. In this case, I want to select Common Airfoil Data. Now let's go to my Documents directory, and let's select our Clark Y 215. So it knows it's a .dat file for airfoil, and it'll import it, and it'll put in something called a wire. Now once you're in CAD, if you're already familiar with CAD operations, you just do whatever you need to do to get the form like you want it, and then print it out. So I'll show you at least one way to do that here. Now, I mentioned before you might want to do offsets. For example, I'm building an aluminum airplane, or at least designing an airplane right now that's aluminum. And I've got 16 thousandths thick aluminum sheet that goes all the way around the wing. And then I have ribs that have flanges on them that rivet to that sheet. That's 20 thousandths thick. Now, if I want to make a form block for my aluminum to bend over those flanges, I'm going to have to make that form block smaller than the skin thickness and that flange thickness. So adding those two together, that's 36 thousandths. And speaking of units and length, FreeCAD is going to import this assuming that the coordinates in that .dat file are in millimeters. The leading edge is going to be at 0, 0, but let's zoom in here at the trailing edge. Now we're going to look down here because this shows us where our pointer is in free space. And we look down there, and we are at roughly 39 thousandths. So this is 1 millimeter right now. And by the way, I should have mentioned it. I've got FreeCAD set up to use default units of inches. So it thinks that's 39 thousandths inches. So we need to scale this first to get it right. Now I'm going to assume a 62-inch chord. Now I'm going to do this in 2 steps. You could actually do it in 1 step if you wanted to, but just to make it a little bit easier to think about how this works, I'm going to do it in 2 steps. So I'm actually first going to scale it so that we are up to 1 inch here for the chord. So I want to make sure it's selected. I come up under modification. I come down to scale. So first thing I want to know is a point. Now I'm just always going to enter 0, 0 here, and that makes it nice because our nose is at 0, 0. It'll leave our nose right there. So let's do that first. So we're going to enter 0, 0, and say enter point. Now I need to scale it. So in order to scale it to 1 inch chord, I need to go to 25.4 millimeters. Now our units are in inches, but it's scaled down because it thought it was millimeters. So let's go to 25.4. 25.4. Now you noticed it actually giving us a preview of what it looks like. Let's zoom out a little bit. So you can kind of do an error check. Does that look about right? So that's about 1 millimeter. That's about 1 inch. So it looks like it's probably about right. Now you'll notice that I only did X and Y here. And that's because we imported it into the XY plane. I want to make a copy of it so I can keep the original around just in case I want to make another template. So let's go ahead and say OK. So now we have a new wire, wire 1. So wire without anything is original one. Here's wire 1. Now I'm going to hide our first one, and I do that by selecting wire and then hitting the space bar, and that hides our original one down here. So now we're scaled up to 1 inch, so that's good, but I really want to be 62 inches. That's basically what we have on the UWS-4 ultralight airplane. So let's go ahead and scale it one more time. So now we're at 1 inch. I need to scale it by 62 to get it up to 62 inches. So let's select wire 1 again. Let's do modify, scale. I still want to leave the nose where it is. So let's do 0, 0. Enter that. Now we enter 62. 62. So there's 1 inch there, and here's 62. That looks like it's probably about right. So let's hit OK. Let's get rid of our 1 inch scale. So now we have our 62 inch chord Clerk Y airfoil. So if you like drawing things on paper, you could actually put this in a technical drawing and then print it out. And then do any extra drawing you like to do. Maybe you're making a wooden rib and you just want to go ahead and just draw out all the portions of your wooden rib design on a piece of paper. You could certainly do that. I would probably do it here in CAD and then print it out. But let's say I want to make an aluminum rib. Now my wing skin is 16 thousandths. My rib flange is 20 thousandths. So I want to offset this airfoil by 36 thousandths. So let's do that. So we select our airfoil, come up under modification, hit offset. Now I'm going to zoom in here a little bit so it's going to be a little easier to see. So you can see this line that's being drawn out from the edge of our airfoil. It's hard to see here, but it's also on this side. So you can just try to do it by eyeball. So if you look up there where we have our distance over in that offset dialog, you can see right there, there's 38. There's 36, 37, 36. So that's actually one way to do it. Let's go ahead and just do that. So I did a click, and now it made another wire. Now we have wire 3. So you can see both of them here. Now here's the bigger one, here's the offset one. So we're now accounting for skin plus flange for a rib. So what we could do is make a form using this inner line here. So let's get rid of our outer one. I've got wire 2 selected. I'm going to hit space. That'll get rid of the outer one. Now you see the inner one. Now remember, we're in the draft workbench. It can do some simple operations, but if you want to do more complex operations, you probably want to be in Sketch. We select our wire 3. We come up under modification, come down to draft to sketch and click that. So now you can see we now have this sketch over here. So let's get rid of our wire. Let's select our sketch and let's double click on it. So now we're in here and you can see where all the vertexes are for our 200 segments of our airfoil. We can actually start making changes here. Let's say we might only want a nose rib. So we could stick a line in here. In fact, why don't we just go ahead and do that just real quick. I don't want to get a lot how to operate FreeCAD, That's really not what the purpose of this video was. It's trying to show you steps in order to get to where you can print something out. So this is going to be pretty simple. In reality, we'd probably do a whole lot more. Let's do something simple here. So let's say our spar is going to be about 19 inches back from the leading edge. I want to put a line in here. Let's go ahead and put a line in here. Oh, and by the way, I didn't mention it, but you'll notice that when we clicked on Sketch and double-clicked on it, it changed our workbench to Sketcher. So I want to put a constraint on this. So come over here to where our constraints are. I'm going to select vertical. I'm going to click on my line. So now it's vertical. I want it to be, let's say, 19 inches from the nose. So we're going to put a distance constraint in here. So I'm going to select on this dot and this vertical line. I'm going to enter 19. And I'm going to say, okay. All right, so now this line is 19 inches back from the leading edge. So that's about right. So now I want to do some trimming and getting rid of all this. I'm only interested in nose rib. So let's get rid of all this. All right, so let's just select it. So you can see all that green. That means I've selected it. I'm going to hit the delete key. I got rid of most of it. Let's get rid of a little more. Delete. All right, now I get rid of that one. I want to trim this excess line here. So I'm going to select this here, trim edge. I'm going to select the part that I want to get rid of. Click that. So I got rid of that. Let's go do the same thing down below. I'm going to get rid of this excess down here. So now I'm going to select that line, get rid of that. Now I want to do trimming again. So this line isn't where the vertex of this line is. So let's do another trim. Select trim edge, select the excess to get rid of, and let's do it at the top. Do the same thing here. So now we have the outline of our nose rib forming block. Let's close this. So now we've come out of our sketching mode. For FreeCAD to make it easy to print this sketch, I actually need to make it into a 3D item. So what I need to do is extrude this sketch. So the way I'm going to make it 3D is I'm going to come up here under our workbenches. I'm going to say part design. Now I need an active body for this sketch to be a part of. Let's create a body. I want to double click it to make sure that it's the active body. So now I can drag this sketch down into my body. So now you see sketch is indented from body. Now we select pad. Okay, now we're almost making it 3D. We need to decide how thick it is. Now this is going to be a form block. I'm going to make it out of some 3/4 inch plywood. So I'm going to put in 0.75. I'm going to say okay. So now it's made it into a 3D block. So let's take a look at it. Oh, we can rotate it around, take a look at it. So you can see it's got some thickness to it now. And you can see all those little edges of our 200 points have now made little panels along here. But that's okay. Let's go ahead and go back to our top view. Now this is good enough to make at least a flange form block. I probably want to have lightning holes in here that we'd add, but for now I'm not going to worry about that. What we want to do next is put this into a technical drawing. So to do that, we come up here under part design. We come down to tech drawing, and we want to make a new technical drawing. We'll have to decide next how big a piece of paper are we going to draw this on. I'm going to put this on some D size, ANSI D size. So I want to create a page using a template. So I select on that. I come down here. Now these are the metric page sizes up here. So I'm going to use architectural D landscape. Okay, so let's go back to our pad. Since I've kind of tweaked around with it, kind of rotated around, I want to make sure it is flat to my view here. So I'm going to hit top again. Now, with pad still selected with it visible, I'm going to come up underneath, insert view. Now this is really a quick and dirty way to do it. In reality, you probably use something like the insert projection group or something like that, but we're going quick and dirty. So let's go ahead and say insert view. Now you'll see that it added this view down here. So let's go back and look at our page. And now you can see the view we were looking at is now in here. Next thing I want to do is add something in here so that I can measure to make sure we have the correct scale when it gets printed out. So let's add a dimension in here. So the way I need to do that is I'm going to create a horizontal dimension from the leading edge back here to this trailing edge. Well, I want to do a horizontal line. There are several ways to do that. One is with two vertexes. So I'm going to come up here to this vertex, select it, come down to another vertex near the leading edge, and I'm going to hold down Control and select it. So we should have two vertexes. Yep, still green. So let's hit that. So it's 19.968 inches. Now ideally this would have been 18.966 to account for the skin not being here at the leading edge and the flange for the rib not being here at the leading edge. But we had that little bit of issue where this nose came out just a little bit past the 00 point when we were first importing it, and it looks like that was about 2000ths of an inch. So that's why we didn't quite get 0.966 here. But this is good enough for what I'm trying to do in this video. Now what I would like to have is a PDF version of this file. So I'm going to come up here in a blank area, I'm going to right click, I'm going to say Export PDF. And then I can export that wherever I want, call it whatever name I want. Let's just call that Clark Y. I'm going to call it 15, and it'll be a .pdf. So now I have a PDF file. Let's go take a look at it. So here's the PDF file of that technical document we just made. What I can do then is put this on a USB drive or send it off to a place that will make printouts for me. Locally, I just go to the local FedEx that does 24-inch by 36D size drawings, plug my USB drive into the machine and print it out. Then typically what I'll do is I'll go ahead and bring it home where I can measure it, although I could take calipers with me and measure it. And I'm going to measure if I got the correct distance along here. Do I have 18.968 inches? Sometimes you won't. So if that's the case, then what you're going to have to do is figure out a scaling change on the printing device itself. So let's say you figured out that it's measuring it just a little bit small. You do the percentage calculation, so whatever your measurement was, divide it by what it should be. That's going to give you a percentage. Let's say it was 99% of what we really wanted, so it's 1% too small. Now a really crude thing to do then would be to tell your printing machine to scale to 101%. That's not going to be exactly accurate. It'll be off by 0.1%. Then you print it out, do another measurement, and it should be pretty darn accurate. Now I'm not an expert on FreeCAD, so there could be better ways to do it, faster ways to do it. But at least this does get the job done. There are other CAD programs that have ways of doing something similar. In fact, there are other ways to do it here with FreeCAD. FreeCAD has macros and some workbenches that you can use to bring in coordinates. They'll give you pop-ups that do scaling for you, basically. But at least with the method I use, you don't have to add in extra workbenches because the workbenches I just talked about that help you with airfoils are extra and you have to load them in. But this way you can do it with the default FreeCAD. Well, I hope some of you found this helpful. I hope it helps you, Thomas. Thanks for watching, guys. Until next time.